All right, this is going to be the Math 137 Unit 2 review. I've picked a few problems from each section to work through on this video. Starting with the verifying identities from number 1, we're looking at the identity secant of theta minus cosine of theta equals sine theta times tan theta. Notice that this has two terms, whereas the side we're trying to transform it into only has one. Typically, this means we're going to have to get some kind of fractions involved and get a common denominator. So I'm going to start by using our technique of changing everything on the left side to sines and cosines. So this would be 1 over cosine theta, because that's the reciprocal of secant, minus, and I can turn this into cosine over 1 just so that they'll also be a fraction. We'll multiply to get a common denominator, so I'm going to multiply this fraction by cosine theta on bottom. Whatever we do to the bottom, we have to do to the top. That would make this 1 minus cosine squared theta on top, all over cosine theta. And then there's a Pythagorean identity, sine squared plus cosine squared equals 1. So that means that 1 minus cosine squared equals sine squared of theta. Now we're down to a single fraction with no adding or subtracting. So to make this into a sine and a tangent, well, we obviously see the sine, but because it's sine squared, maybe we can split it into two sines, and they're over the cosine. So the one that's just the sine on top first, we can leave as sine. Sine over cosine will turn into tangent. And we have proven the identity. Let's look at C. This one is cosine theta over 1 minus sine theta equals 1 plus sine theta over cosine theta. So notice the big thing here that I note that makes me try a different technique for this one is that we have a binomial in the bottom on this side, but a binomial on top on the right side. And notice the sign is negative, and over here it's positive. Typically that means we needed to involve a conjugate. Remember, the conjugate is just the same binomial, but you change the sign in the middle. So we're going to multiply top and bottom of that first side by 1 plus sine theta. On the top, I'm just going to leave it as cosine theta times 1 plus sine theta. You don't always know if you need to distribute that or not, so I'm just going to leave it alone. On the bottom, we would FOIL. This is 1 plus sine theta minus sine theta, and then minus sine squared theta. Again, this is a Pythagorean identity on the bottom. So this would be cosine theta times 1 plus sine theta all over cosine squared theta. And then one of the cosines on top can cancel with one of the cosines on bottom. So this would be 1 plus sine theta over cosine theta. Now, when your binomial is on top, you could split it into two separate fractions, but I don't need to in this specific problem because that is what the right side is. So we've already created the right side. And I know I did these two in class, but I'm focusing on those two because they're similar to the ones that were on your quiz. And that is what we said you should stress over. So find all solutions of the equations in radians. So we're looking at number 2. I'm going to do part B. So notice this has a very intricate inside for the angle. So what we need to do is actually just focus on what is cosine of some angle, and that it would equal a ratio of square root of 2 over 2. So we're kind of letting alpha stand in for 4 theta minus pi over 4. So I'm just asking, when is cosine of an alpha equal a square root of 2 over 2? So cosine is positive in quad 1 and quad 4. And for it to be a square root of 2 over 2, it's going to be a 45-degree angle, but we want it in radians, so that's pi over 4. And this would be 7 pi over 4. So we know that alpha should equal pi over 4 plus 2 pi n. Since they did say find all the solutions, that's when you know to add the plus 2 pi n. So one of my solutions would be pi over 4 plus 2 pi n. The other one would be 7 pi over 4 plus 2 pi n. The problem is the alpha we solved for is not the original angle. Remember, the original angle was this 4 theta minus pi over 4. So we need to set that, this is called back substituting, equal to our angles that we solved for. And then we're going to solve for the theta. So that means we're going to add over pi over 4. So that makes this one 4 theta equals 2 pi over 4, which would just be pi over 2, plus 2 pi n. Add over pi over 4, that's going to make this 4 theta equals 8 pi over 4, which would be 2 pi plus 2 pi n. And then since this is 4 theta, we need to divide or multiply everything by 1/4, which is a little easier when there are fractions involved. So the first answer is theta equals 4 times 2, since they're both on bottom, would be pi over 8. 2 over 4 would be 1/2, so pi over 2 n. So there's my first solution. My second solution, I'm going to divide everything by the 1/4, or multiply by the 1/4, I should say. So this will be theta equals pi over 2 plus pi over 2 n. And that's it for that one. So let's try another variation. Let's look at C. We've got 3 minus tan squared, and that one is equal to 0. Now, if that was a perfect square, like if that was a 4 at the beginning, we could try factoring. But since it's not, I'm just going to subtract over the 3 and isolate this tan squared. Since they're both negative, we wouldn't leave it like that, so we divide both sides by a -1. And then we're going to take the square root to get tan by itself. And when you take a square root, you physically have to write plus or minus on the other side. So we're looking at plus or minus the square root of 3. So this is actually 2 different branches of tangent that we have to solve. The first branch we need to solve, and I'm going to go ahead and write this as positive square root of 3 over 1, because I always like to think of things in fraction format when I'm doing my ratios. And then this one would be tangent of theta equals negative square root of 3 over 1. Now, the thing about tangent that's a little hard is that square root of 3 over 1 really relates to something that was square root of 3 over 2 over 1/2. The 2's have already been reduced or canceled out. So this means that, first of all, we need to figure out where tangent would be positive. That would be in quad 1. So imagine a triangle there, and it would also be in quad 3. When you have tangent, it's opposite over adjacent. So that means this is square root of 3 over 2, and this is 1/2, because this is my theta. Whenever you're dealing with the 30, 60, 90, if it's 1/2 and square root of 3 over 2, square root of 3 over 2 is always across from the 60-degree angle. So this is actually pi over 3, and that helps you figure out what this radian is. So this would be 3 pi over 3 is pi, so this is 4 pi over 3. And are we doing all solutions again? Yes. Now, luckily, we're not going to have to do any back substituting here because the inside angle we were solving for is theta. It wasn't anything with a parentheses. So one path would be theta equals pi over 3 plus 2 pi n. Another path of solution would be 4 pi over 3 plus 2 pi n. And then we need to solve this version, which is going to be exactly the same, except it's going to be in the other quadrants where it would be a negative square root of 3 over 1. So this one is going to be 2 pi over 3, and this one down here is going to be 5 pi over 3. So then we also have 2 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. Now remember, sometimes people will combine the ones that are 180 degrees away from each other instead of doing plus 2 pi n. They'll just make it pi n. I don't really want you to worry about that. I would rather you just write out all 4 separate answers. Okay, let's look at F in this same one. So this one is cotangent squared of theta minus 3. So I would go cotangent squared of theta equals 3. I would flip this and make it tan squared of theta equals 1 over 3. And then I would take my square root. So this is going to be plus or minus the square root of 1/3, which is going to be tangent theta equals plus or minus the square root of 1 is 1 over the square root of 3. We're going to rationalize that denominator. Or you don't even have to, actually. Because we don't really care so much about it being rationalized, we can think of this as plus or minus 1/2 over square root of 3 over 2. So this is just exactly the opposite. The 1/2 is on top and the square root of 3 over 2 is on bottom. That means I already kind of know where this is going. tangent of theta equal to a positive 1 over square root of 3 is going to again be in quad 1 and 3 because it's positive, but it's the 1/2 is the opposite. So this is actually a 30-degree angle. So this is pi over 6. This is 7 pi over 6. And then for the tan theta equals the negative 1 over square root of 3, it's going to be in the quad 2 and 4 with the same reference angle since it's still the same ratio. So this would be 5 pi over 6 and 11 pi over 6. So my angle answers are going to be pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n and 7 pi over 6 plus 2 pi n and then 11 pi over 6 plus 2 pi n. There's everything for that one.